So just a reminder from yesterday, our process for this is pick one of the variables to isolate from two different systems. So I did 1, 2, and 1, 3. And sometimes it's helpful. You notice that we're isolating, or not isolating, but eliminating y. And this is one of the places that sometimes students mess up, is they eliminate two variables instead of one. So two systems, one variable. Get rid of it. And the reason why is because these come together to make a system of two variables that we can solve. From there we can solve for one of them, like usual. Of course, where else can you make mistakes on these? Are you finding that out? Like little teeny things, dropped the negative, subtracted wrong, wrote the wrong, like 3 times 3 is 6, like those kind of things cost, right? It messes everybody up. And it's part of it, guys. It's going to happen. It even happens when I do it occasionally. Can you take that out? So just do your best to pay attention to every little detail. Maybe even double check every step. So we combined these two and got rid of y. We had to scale equation 1 to make 1a, and then we got rid of y there. So maybe just make sure you're not using that one again. And here we are trying to get rid of either x or z, and I think we figured out yesterday that z would be better, if I recall. So how are we going to do that? Probably didn't need this yet. How should we get rid of z?
Multiply by 9 by 4.
Okay. So both need to be scaled in order to match the coefficient. So we'll do 9 and 4, and of course we're distributing all the way across. So 4a will be 36x plus 36z, and that equals 36. We had that weird case where it was all 4s. 5a will be 52x plus 36z equals negative 12. And what operation should we do to get rid of those z's? Yeah, they're same sign, so 36 minus 36. I still encourage you to make sure that that's obvious, like make it big, circle it, show what you're doing for you, really, like now you don't forget. Okay, 36 minus 52, I think that's negative 16. And then 36 minus 12 is, what is that, negative 26? No, yeah, positive 26. Positive 24. Sorry. Okay? Oh, I still screwed up. Can you see what I mean? I do too. Tell me what I did wrong. What's minus negative become?
Positive.
Yeah, it becomes addition, so this really should be 48. Okay. Now we get negative 3 when we divide by negative 16. Whew. Narrowly missed that. Okay. Now, don't think that every single one of these is always whole numbers, because unfortunately sometimes they're not. But I do like the whole number ones better. Okay, so we have one of these. Now what do we do? Remember from here it's a lot easier. Like the steps kind of just get easier and easier. Go ahead, Stephanie. I'm pretty sure you said the correct thing. Yeah. Where would you like to have that plugged in? We have several options. Well, you can plug it in 2, but then do you see, we'll know x, but we'll still have y and z that we don't know. So we want to plug it somewhere where there's only one other variable instead of 2. So I would say 5a, 4a, or 4 and 5. Out of those, which one is the easiest? For you. Most people are going to say 4. So everybody agree? Okay, so we take this into equation 4, and that would be 4, and then leave, in parentheses, leave a spot to plug in the negative 3. So 4x plus 4z equals 4. And that guy goes right there. So negative 12 plus 4z equals 4. Add your 12, 4z equals 16, and z equals 4. Okay. Now what? Yep, plug. Now we have x and z. We take those back to one of the originals to solve for the last variable, which is y. To me, equation 1 looks the best because y is positive and just by itself. So let's, I think, go there. Help me remember 2x plus y plus z equals negative 2. So now we are solving for y, solve for y. 2 times negative 3 plus y plus 4. I don't really need those parentheses, but just so we know, I'm plugging that in. So this is negative 6 plus 4, which is negative 2. Add your 2, and then we get y equals 0. So we've circled each of the ones that we got, each answer, but what do we do with them to make our final? Yeah. So negative 3, 0, and 4. Those of you who did it last night, how did you do? Yeah, lots of thumbs up. Cool. Okay. That's a pretty typical process for these. Occasionally you'll get one where you can cancel two things at once and you can solve for a variable earlier on. Sometimes you get a 0 earlier on and that makes the solving easier. I just happened to solve for y last, otherwise it would have helped. But if we zoom out on this, it's a pretty typical looking problem. So I typically give you lots of room when I have these on like a test paper. But here's a couple things to note. You can follow my work really well. Like anybody could come in here and see I started with 2 systems and then work through to eliminate successive variables and solve. I want you to do it that way. If your work is hard to follow, I can't really give you partial credit if you're wrong. Okay? I do try, but if your work is number 1 messy and number 2 I can't really tell what you did, if you got all 3 answers wrong, you probably just won't get any points. And these are usually worth like 6 or 7 points because it's a lot of work, right? So show your work neatly and make it easy to follow. Okay, I'm going to have you try one on your own. And how long do you think these are? 10-minute problem? Let's go with 10. Actually, before you do that, I'm going to attach that work on a separate example. But you get 3, 1, negative 2. Okay. Guys, what would it look like on one of these I mentioned earlier about getting no solution? What would that look like in one of these? I don't want to have us do one. I just want you to think through how that would look. Yeah.
You plug a variable back in and it tells you the number back.
Okay. Which could also be that you solved it wrong.
Oh yeah. There is a decimal 3.
Hold on one second. So how would you know it's no solution?
Get a false expression.
Yeah, like you're working through, let's go back to this one. Let's say like somewhere in here I got negative 16 equals 48. Well, no. As soon as you get something like that, you should check your work and make sure you did it right. But if you get something like negative 16 equals 48, then this has no solution. You don't need to continue doing a bunch of work. Okay? again, I would check to make sure that something didn't go wrong. But like CJ said, if we have a false or not true equation like that, it's no solution. And you might run across that. Okay? Alright, Casey, what were you going to tell us?
Just that I found the 3D.
Will you share it? Like, or tell me, like, what, does it have a separate name?
Yeah, it's just, there's a tools button in the corner.
Let me go there.
Top right.
Top right?
Where's the Desmos icon? Top right.
This guy, right? Everybody look here. You want to use Desmos to check? Green button.
That's the bottom.
3D calculator.
Yeah, because when you're on that screen right there,
Cool.
you click Z, it
Oh my goodness.
So now it's graphing in 3D. Let's go ahead and try this. So we get x plus, if you want to pull yours out and try this too, that would be cool. If you're fast. Equals 12. Alright? 3x minus y plus 4z equals 0. Is it making sense to your eyes at all? Negative x plus 2y minus z equals 1. Alright. I think probably we can manipulate this around, yeah. That's cool, huh? You don't care for that? Okay, what are we looking for to find the solution of all three of these?
the one where we're all doing.
Yeah, we need to get all of them to cross at one point. So I see blue and green. Where's my red one? Right there.
Yeah.
I'm seeing it right there, maybe?
Yeah.
Here, let's see how that does for you. Is anybody getting dizzy? Alright, it says welcome to Desmos 3D beta. So probably not ready to solve using this yet. Your calculator can do it though. Would you like me to show you that?
Yes, please.
Okay, why don't you grab it? You have no idea. Alright, everybody grab your calculator if you don't have one. The NumWorks one does it a little easier than the TI. You could pull it up on just online. Just Google NumWorks graphing calculator. Real quick, I do need to show you something called a matrix. That's how your calculator solves this. So don't get involved in your calculator just yet because you'll need to know how to enter this into it using matrices. So a matrix, guys, these are pretty cool things. There's all sorts of things you can do with matrices. We probably won't have time to do much of it, but basically we're going to peel the coefficients off of each of these and write only those into like this little grid called a matrix. Okay, so I'll just do one for you. This one, what's the coefficient of x? 1. Then I write 3, negative 3, and then 12 is the on the other side of the equal sign. Okay, and then 3, negative 1, 4, 0, negative 1, 2, negative 1, 1. So basically, this is the matrix, and this is what we're going to enter into the calculator. This is the x column, y column, z column, and the equals column, or answer column. To solve this, what we want, it's called, your calculator calls it, it's lowercase, I think, RREF. So reduced row echelon form. You know, we like to make stuff complicated sometimes. But in your calculator, the command is RREF. And what we're looking for is this case. It's going to put the results into another matrix that looks like this. And what it means is 1x equals whatever number is there. 1y equals whatever number is there. 1z and then equals whatever number it puts there. Everybody clear on what we're looking for? Okay, so RREF is the solve command. So grab your calculator, and I don't want to switch back and forth, so I'm going to use the coefficients off here. Right up here on the left side, kind of middle, above the x to the negative 1, you see the command matrix. So second matrix, yeah.
Desmos also has a matrix calculator.
Okay, so we could probably do this in Matrix too, or in Desmos. Okay. Sorry, I hit the wrong button. Go to Edit, and that's going to allow us to enter our data. Now, this is saying what size. We don't want 1 by 1, so we want, go back. We want 3 rows by 4 columns. So we want a 3 by 4 matrix. So 3 by 4. So now it should look like what we just wrote down. And now we just go through and we type in our coefficient. So 1, enter, 3, enter, negative 3, enter, 12. And that was our first line. So 1x, 3y, negative 3z, etc. Okay, the next row, 3, negative 1, 4, 0. And then last, negative 1, 2, negative 1, and 1. Okay, so we have all our information entered from our equations into the matrix. And you just leave it, go back to the home screen. So second mode is quit back to the home screen. I'm taking that out. Everybody good? So second matrix edit to enter all that stuff in. And then we come back here to tell it to solve. So we need to do RREF, that's our command. If you go to the catalog, it puts up an alphabetical list of all the commands for this. I can't really read these. There's R. So if I go to R and just scroll, probably a shorter way to do this, but there it is. RREF. Okay. RREF. And then I have to go tell it which matrix. So you go back into matrix, and then you just hit enter on matrix A. That's where we put our data. Okay, and then you hit enter. And then remember what I said. This is 1x equals 3, 1y equals 1. And 1z equals negative 2, and that's the answer that we got. It just solves it instantly for you. Now, admittedly, this TI calculator is kind of an outdated interface, right? That's a lot of clicking around. So the NumWorks calculator, it has, let me show you it, because this is free online. Like, that's what I'm using. I don't have any subscription or anything. Why am I on College Board? Here, I'll just show you what I do. NumWorks calculator, online simulator. You guys can do all this on your own. Now, it has a pretty cool thing. Do you see the top right option? Equations. And then you just type in the equations. You don't have to go through all that matrix stuff. So I could just type in this problem the way that we just saw it on paper. And so I would have the first, second, and third, like x plus 3y, x plus, I don't want to do the whole thing, but enter it in, and then you just go down and solve, and it will solve for you. So it's definitely faster. And then those guys are saying there's a matrix calculator on Desmos. So 3 options. But homework is going to come off of OpenStax. In fact, let me put it up here right now. Man, this thing is doing weird stuff. I better quit before it. Everybody look up at the screen while I show you this. So you're going to do some of these problems off of OpenStax. I'm just having you do 3. Listen. So 167, 69, and 85. So let's look at those. Yeah. Do double check that you wrote it down correctly before solving. No. Thanks. Here's what they look like. Thank you for telling me. So like 167, 169, and then 185. Those are all odd, so you can check your work. But also try using Desmos, Gnomeworks, or your calculator to check too. Okay. We will be moving on tomorrow, so make a good effort on these.